So let's take a look at division. And I want to start simple so we can start to see again where these procedures, where these algorithms come from. If you have a whole or even two wholes, and you want to cut it in or divide it by, and so this is also where the language is tough, right? Divide it by 3. This is one whole divided by 1/3. And what do you get? If we think about this as 1 divided by 1/3, we want to think about it as how many 1/3 pieces fit in. And likewise, if we wanted to think about, clear that then, two wholes. So we have 2 divided by 1/3. We can think about it as how many 1/3 pieces fit into 2, right? If 3 fit into 1, then 6 fit into 2. And so, and if we did 1 divided by 1/3 is 3. So if we keep going, what's 3 divided by 1/3? Yep, 9. What's 4 divided by 1/3? 12, right? So we start to see this relationship and we can start to see a pattern. This is the same as 1 times 3 is 3. This is the same as 2 times 3. Is 6. This is the same as 3 times 3 is 6. 9. So by using the tools and starting out with easy numbers, right? Numbers that we can easily see, and understanding this idea of division of like how many can fit in, right? How many groups of 1/3 can we make if we have one whole? Then we get to see, right? That's our measurement division. How many groups of 1/3 fit in? Each group is 1/3 long. How many groups do we have? How many groups can we make? Then we start to see this procedure of, oh, look, it's multiply by the reciprocal every time, multiply by the reciprocal. But now what I want you to think about is, well, what if it wasn't 1/3, but what if it was 2/3? So what if we had 2 divided by 2/3? Well, we want to use that same reasoning. Well, here's one group of 2/3, another group of 2/3, and a third group of 2/3. So 2 divided by 2/3 is 1, 2, 3, 3, which is the same as, right, 2 times 3 divided by 2, right? We still see the same exact procedure, but it doesn't really have to do anything with the flipping. It has to do with this, how many times 2/3 fit into this this dividend, right? How many times 2/3 fits into 2. Because let's clear all this. And what if we didn't want 2/3 into 2, but what if we wanted 2/3, 2/3 into, or 1 divided by 2/3? How do we see this? Well, 2/3 goes into 1 time, and then what's this left over? This is not a whole 2/3, it's only a 1/3. So does that mean the answer is 1 1/3? Right? I see, no. We want to think about what's this 1/3 in relation to the divisor. 1/3 is half of the divisor. So 2/3 goes into or fits into one whole time, right? Here's one whole time and a half of a time. Half of 2/3, right? This 1/3 is half of 2/3. So it's how many times does it fit in? And this is that same exact, right? 1 times 3/2, right? We still see this same exact procedure of keep, multiply by the reciprocal. I don't like saying keep, change, flip, because that doesn't help anybody. It might be a good thing to work towards, but your students need to come up with that language themselves. We don't want to say that to them. We want them to make sense that when we're thinking about division and we know how big each group is, right? Each group, if we're thinking about this in that measurement division and how many groups, means each group is 2/3. How many times does 2/3, right? How many times does it fit in there? It fits in one whole time and a half of a time, right? This is a half of 2/3. So what if we did the same, but we thought about 2 divided by 2/5? We just did 2 divided by 2/3. So think about, right? I want to see how many of my 2/5 fit into. So we can line up. That's one time. Here's now a second time. And this is where 1 time, 2 times. We can do it another time. And another time. So now we're at 3 times, 4 times. And then I think you can guess it, right? 5 times. And again, this is where we get this procedure of 2 times 5/2, right? 2/5 fit in 1 time, 2 times, 3 times, 4 times, 5 times. So this is how I want you to be thinking about fractions and fraction division. It's going to be the same if you had fraction divided by a fraction. It's how many times does the divisor fit into that dividend. And